All right, this is for 5.3 exponential functions. We're going to look at some of the basic operations with exponential functions and the graphs. So first, just to go over some of the exponential rules you should already be comfortable with. This is just reminding you that if you are multiplying two things with the same base with exponents, you really just end up adding the exponents. If you're raising something with a power to another power, this is when you multiply. So these are the two that people confuse the most. So make sure you see when you add and when you multiply. This is just reminding you that 1 to any power is still going to be 1. This is showing you that if you have multiple things raised to a power, you can split it up by raising each thing to that power. This is a big one for this unit. To remember that if you have something raised to a negative power, that is the same, and we will usually change it to 1 over that thing raised to the positive version. So for instance, if you had 3 to the negative 2, that is the same as 1 over 3 to the second, which is really 1 over 9. And then finally, anything raised to the 0 power is just 1. Okay, so now to start looking at these graphs. An exponential function is something that would look like this, where c is some number, oftentimes just a 1, so there might be nothing there, and then some kind of base number raised to the x. Okay, a is going to be a number greater than 0. It's not going to be 1 because otherwise the whole thing would just equal 1. And c, the number in front, is never going to be 0. Otherwise, that would just wipe out this whole function. The domain you're going to see when we start graphing is going to end up being all real numbers. And if nothing has been added or subtracted, if it's just the most basic version of this, you are always going to have a horizontal asymptote at y equals 0. So a, the base number, we're going to call the growth factor. You're going to find out that if a is greater than 1, it will mean there is a growth. And if a is between 0 and 1, it will mean there is a decay. So we'll see that in a minute. And c, the number out front, is going to end up just always being the initial value of the function. So that will make more sense when we start actually graphing some of these. So here's an example of an exponential function. So in this case, a is 2, c is 1. That's why there's no other number out front. And we can go ahead and start filling in a chart to see what the graph's going to look like. Since nothing's been added or subtracted, we know that there is a horizontal asymptote at y equals 0. So we could start by graphing that. If I plugged in -1 to x, that would give me 2 to the -1. But remember, that really means 1 over 2 to the first power. So it's just 1/2. If I plug in 0, 2 to the 0 power, as we saw up there, is going to be 1. 2 to the first power is just 2. 2 to the second power is 2 times 2, or 4. So you won't always have to show all this work, but it might be a good idea at first to get used to dealing with negatives and zeros with exponents. So if I plot these points, -1, 1/2, 0, 1, 1, 2, and 2, 4. And if I go towards the asymptote like we know we usually do, you're going to see you're going to end up having something like that. If it was the same exact equation, but it was something like 5 to the x, it would look the exact same, except just go up at a faster rate. So it would just kind of be a steeper curve. Okay? So what if instead of 2, because that's a number greater than 1, which we saw was called a growth. Do you see now why it's called a growth? Because this function just keeps growing and growing exponentially. If it was 1/2, supposedly, according to this, since that's between 0 and 1, it's supposed to be a decay. So let's see why it's called a decay. So If we plug in -2, remember 1/2 to the -2 is really going to flip this. And so it'll become 2/1 or just 2 to the second, which is 4. If I plug in a -1, same thing. It's just going to flip it to 2/1 to the first power. So that's just 2. If I plug in 0, anything to the 0 is 1. And if I plug in 1, I would get 1/2. Again, though, nothing's being added or subtracted, so I do still have a horizontal asymptote at y equals 0. But now if I plot -2, 4, -1, 2, 0, 1, 1, 1/2, do you see why this is called a decay? Because this time it's going down from left to right instead of going up. So now does this make a little more sense that if the A, the base number here, is larger than 1, it will be a growth. If it's a number between 0 and 1, it will be a decay. So let's do one more. So if this is my function, we already should have an idea that this is going to look similar to 2 to the x. But just to plug in some numbers, 3 to the -2 means 1/3 to the +2. So that is 1/9. 3 to the -1 is 1/3 to the +1, which is 1/3. Again, I'm not always going to show all this work, and you won't need to either, but it might take a little practice to get used to these negatives and what they do, and the fact that anything to the 0 is always going to be 1. 3 to the first and 3 to the second is a little more understandable. So nothing's being added or subtracted, so my asymptote should still be the exact same. And we already know that it's going to look like a growth, but let's just make sure. So -2 to the 1/9 is pretty small. -1 to the 1/3 is a tiny bit bigger. 0, 1, 1, 3, and 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So like I said, it'll look very similar to the 2 to the x. It's just going to go up at a faster rate because we're going up by 3s, 3 to the first, 3 to the second, 3 to the third instead of 2. Okay, so just a reminder down here, if a is greater than 1, it's increasing, which also means it is a growth. If it's between 0 and 1, it is decreasing or a decay. So now what happens when we start doing these transformation rules, like adding and subtracting? Okay, that's going to start moving our graphs left, right, up and down, just like they always do. But it's just a little more tricky to do with these types of graphs because we don't have like a nice starting point with our parabolas. Remember, we always had that nice vertex. We could just move that vertex around and go from there. So there's another way to do this that makes it a little easier to find your points instead of just trying to eyeball it. And so the way you would do something like this that has obvious transformations happening is start with the parent graph and remind yourself what that was originally. So 2 to the -1, 2 to the 0, 2 to the first, 2 to the second. And now deal with the transformations on the chart. So the way you do that is you basically do what it says, but you remember that for the x's, it's always the opposite. So keep in mind that when you had -1 inside a function before, that always meant it actually went to the right. So same idea, because it goes to the right, what it ends up doing is adding 1 to all of the x's. But this +3 out here just moves us up 3. So you keep it the same. So basically, whatever transformations are having here, we're going to do the opposite type operation to the x's. Anything out front that affects the y, we're going to do as is. So how do I do this now? I add 1 and add 3 to these numbers. So I don't need to go up here and do all the work again. So -1 plus 1, 0 plus 1, 1 plus 1, 2 plus 1. Done. 1/2 plus 3, 1 plus 3, 2 plus 3, and 4 plus 3. So now I just plot those points. But first, my asymptote is normally y equals 0, right? So moving that to the left and the right isn't going to change it because it goes forever. But if the graph has shifted up or down, that will affect my asymptote. So because this graph supposedly is moving 3 up, my asymptote is also moving 3 up. So I always think about what happens to the asymptote first. Then I graph my points because now I have a guideline to kind of graph. So 0, 3.5, 1, 4, 2, 5, 3, 7. And so thanks to the asymptote, we know that we're most likely coming from this direction and doing something like that. Okay, so let's look at the next one. What would be the parent graph if I see -3, x plus 1 minus 2? Well, it would just be 3 to the x. So I'm going to first do my 3 to the x points. So that would be 1/3, 1, 3, and 9. And so now what has happened? The only thing inside the function is this plus 1. So I do the opposite. But outside, I have this -2 and this times -1. So I'm going to need to do both of those things to my y numbers. I'm going to have to multiply them by a negative and subtract 2. So first for the x's, -1 gives me -2, -1, 0, and 1. For the y's, it's a little trickier. I have to multiply this by a negative and then subtract 2. So -1/3 minus 2 is -2 1/3. -1 minus 2, -3 minus 2, and -9 minus 2. So we might not have room for that one. So asymptote. My asymptote is normally at y equals 0, but this graph has moved down 2. So has my asymptote. And so my points I can graph are -2, -2.5, -1, -3, 0, 5. And this is looking weird. So let's make sure we did this right. Because 3 would be like this and it should flip over. So we should be going down. So I think it is this one. -1/3 minus 2. Oh, it is. I just graphed this weird. -2 1/3 would be way up here. Okay. So I just graphed my point right. I think these are all fine. So -2 1/3, -1, -3, 0, 5 is down here somewhere, and 1, -11 is way down there. So now if I go through these, it should look like this. So I knew something was wrong when I had 1 down here, 1 up here, and 1 down here, because that would never be the shape of this graph. Okay? And this makes sense because our graph has moved left 1, down 2, but then because of the negative flipped over the line. Okay, finally, I just want to show you one with an E so you don't think there's something totally different to do here. E is just a number. It is like pi. So you know how pi is really 3.14, blah, 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 blah. E is 2.71, blah, 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 blah. So it's just a number. So when I plug in a -1, it's just 1/e, which is a decimal that we can put in our calculator. So I'll put it in there just to estimate about where to graph it. So that's about 0.4. 0 would still give us 1. 1 would give us e, which is about 2.7. And e squared, I'll put in the calculator, is about 7.4. So we do have decimals. We will have to estimate a little bit, but nothing else is different about this. Because nothing's been added or subtracted, I would still have my same asymptote at y equals 0. So negative 1.4 would be about there. 0, 1, 1, 2.7, 2, 7.4. So it would again come through here like that. If they ask the domain of this, it is all real numbers. So we're going to the left and to the right forever. If they asked you the range of this, it would be 0 to infinity. So don't panic when you see an E, just think of it as a number and get out your calculator if you need to kind of estimate where it's at. Okay, so last thing about these graphs is now that you kind of know how they work, if you see a chart like this, you should recognize that this is an exponential function because you see that we're kind of going by powers of 3, right? 1/3 makes sense if there was a negative exponent. 0, 1 is what we get with any of these exponential functions. 1, 3, 2, 9. So obviously we're going by powers of 3. So is it a line? No. Is it an exponential? Yes. And because we're going by powers of 3, the equation would be 3 to the x. So just take a second and make sure that makes sense. If I plug in a negative 1, I'd get 1/3, yes. If I plug in a 0, I'd get 1. Okay, so I'm good. So if you want to take a second and try this one before I do, these are fractions, but the key is I usually start with the 1 because that's probably going to be the base number, and then I just see if it makes sense with all the other stuff that's there. So in this case, yes, it does make sense. So the problem would be 4/5 to the x, which just as a review would mean it would be a decay because 4/5 is less than 1. Okay, and then just for some homework questions, suppose that g of x was this. What would be g of -1? Well, you would just plug in -1, so you would get 5 to the -1 plus 5. 5 to the -1 is 1/5. So 1/5 plus 5 is 5 1/5, or 26/5. And you can use a calculator to do these fractions if you need to. So I'm just going to put it in its its fraction form. So what would the point be? -1, 26/5. That's it. So it's a little complicated the way they ask it, but they're basically just asking you to plug in an x and give them the y and then write it as a point. So this time, the way they wrote it, they've really given you the y value. So that's a little trickier. So you would plug in 30 for the y and then solve it. So in this case, you would subtract 5. And we haven't really done these yet, but you could kind of think through this one. 5 to what power would be 25? The second power. So apparently when y is 30, x is 2, so the point would be 2/30. So this one will make more sense after you watch the video on solving equations, but hopefully you can at least see how I could think through that one for now. But I just want to make sure you weren't confused by the way these were set up. Okay, that's it for the graphs of exponential equations. Let me know if you need any more help or if you have trouble with the homework.